Hey, geometry students, this is Mr. Sheck coming to you with there we go, with your Unit 3 review video. So I like to do this to give you a video to guide yourself through the review. So if I'm not there, you can hopefully have your answer or your questions answered by this video. Uh, or even if I am there and you're watching this in class, well, then you don't have to ask me for everything and feel like you're bothering me or anything, even though you're not. I love being asked questions. It's actually my job to answer questions. So don't be shy to do that either. But here's this video for you. Remember, I'm going to go very fast through these. I got to get home to my wife to eat dinner. She's cooking dinner right now. So I got to go fast, remember, but it's a video. So please remember to pause, rewind if something didn't make sense. It's gonna be fast, so I don't expect you, and I don't want you to just watch this without pausing, without rewinding, thinking about what I'm saying, because that's the point of this, to understand this, because this is what's going to be on your test. So you need to know how to do these types of problems. Okay, obviously it's not the exact same questions, but it's very similar. These types of problems are what you have to know how to do. So understand how to tackle any problem like each and every one of these. Okay, so the first one, we have a reflection mapping -3, 2 onto 2, -3. So if you notice here, it's just your x and y are flipping. And when your x and y are flipping, that is when you are reflecting over the line y equals x. That's one of the rules that will be projected. It's just when you're reflecting over the line y equals x, you just flip your x and y. That's how you know that's your answer. Okay, a point in quadrant 2. Okay, so visualize this real quick. Quadrant 2 is right here. Okay, so a point's up here. It's reflected over the x-axis. So it's going to become over here, right? This is my x-axis, this is my y-axis. So if I'm reflecting it over here, well, it's now down here, and then translated left, now going this way. Which quadrant contains the point? Well, either way, it's still down here in quadrant 3. Okay, going on now. And we are supposed to find the vector that translates A, B, and C to A prime, B prime, C prime. So it's really, you just choose one of the points. I'm going to choose B here. So my original B is 6, 3. Doesn't matter which point I choose, as long as I choose its prime. So, whoops, this is just B. So if I choose B here, I need to choose B prime, and B prime is at -3, -2. And I just need to see, okay, well, what's going on? My x's, how do I get from 6 to -3? Well, that's subtracting 9, so that's the x part of my vector. And then how do I get from 3 to -2? That's what my y is doing, and that's subtracting 5, so that is my y part of my vector. This was just there for you if you wanted to visualize what was going on, but you can easily do it just this way. I know we're all capable of just doing it this way without visualizing it completely. So that's your answer there. Moving on down, if you have an equilateral triangle and it is transformed using the coordinate rule, 0.75 times x, 0.75 times y, which properties are preserved in the transformation? Okay, so first you need to recognize this is a dilation because it is being multiplied by your variables, and dilations preserve angle measure. They actually change the height they change the height and the area because you're changing your size. And if you're changing your size, well, then it's also changing your side lengths or segment lengths, but it does not change orientation. So the two that did, wow, my pencil is terrible. The two that are not being changed here are your angle measure and your orientation. Okay, and that's what it means to preserve, to not change. Okay. Now a square sign hangs from the ceiling with a light behind the center of the sign. The light produces a shadow that is a dilation by a scale factor of 1.5 with the center of dilation at the center of the sign. Which statement is true? Okay, you just got to read through each of all of these, and we should know that all sides of the image are parallel to the corresponding pre-image sides. Okay, so think about each of those. I'm not going to spend a whole lot of time on that one. If you need further explanation on that one, ask about it in class. Moving on. Okay, number 6 is where we're at now. And it is asking about a square with vertices given to you. It's being dilated by a scale factor of 5. And then it wants to know what is the length of the diagonal in the in the image square to the nearest tenth of a unit. Okay, so really you can pick any two that are not right next to each other. Like if this were A, this were B, and this were C, and this were D. Well, B and D are going to be diagonal of each other, and A and C are going to be diagonal of each other. So I'm just going to use B and D. And if B is at 0, 4, and D is at negative 5, 1, again, hopefully you agree. And if you could plot these, you would see that these two are diagonal of each other. And then they're being dilated by a scale factor of 5. So B prime is going to be, well, 0 times 5 is just 0. 4 times 5 is 20. And then D prime is going to be negative 5 times 5, that's negative 25. And 1 times 5 is 5. So these are going to be my new points after the dilation occurs. Okay, and then if I'm going to find the distance between these, because it's wanting to know the length of the diagonal, then once again, our good old friend distance formula is going to come back into play. And here's distance formula. I'll write it up here at the top. It says that distance equals the square root of x1 minus x2 squared, or x2 minus x1. It doesn't matter, actually, but we'll say it that way because that's the way it's always been given to you. Plus y2 minus y1 squared. Now that is your distance formula. So we're just going to plug it into that. Okay. So again, it's the square root. These are written as x comma y. X comma y. Okay. So x2 minus x1, negative 25 minus 0. Well, that's just going to be negative 25. And that's going to be squared. Plus, now y2 minus y1, 5 minus 20 is negative 15. Okay? And then we just go ahead and get out our calculator, and I can go ahead and do negative 25 squared. That's going to be 625. Remember, anytime you're squaring a negative, it should be a positive. And then 15 squared is going to be 225. Then I just have to add those up, and that's going to be 850, which means my answer is the square root of 850, which you can leave it as that, or if you go ahead and put in square root of 850 in your calculator as a decimal to the nearest tenth, it does say to the nearest tenth, so that is going to be 29.15, which just rounds up to 29.2. Okay, so that's how you would tackle a problem like that. Moving on down to number 7. Again, I know I'm going fast. I have to. I got things to get to, but this is a video. Pause it, rewind it if I'm going too fast, which I probably am. Okay. First, we have these 3 points. Okay, and it is then being rotated 180 degrees, translated down 2 units, and dilated by a scale factor of 4 centered at the origin. And now it's only asking for the coordinates of A, or A2. And A2 is going to be after all this happens to it. So this whole time I am dealing with A, and I don't really need to worry about the others. Okay? So let's do this. If it's being rotated 180 degrees, well, the rule for that is just to to flip around your x and y. Okay, so I flipped my x and y. Negative 1, comma 3 became 3, comma negative 1. This is after the rotation. That's what it becomes. Now, next, I have to translate it down 2 unit, units. So when I translate that down 2 units, if I'm going down, my x is still going to stay as 3 because I'm not moving left or right at all. And then I just need to go down 2 units. Negative 1 minus 2 is going to be negative 3. Okay. Now, sorry, I just want to make sure something is right here. I'm looking at my answer key that I made, and I think I made a mistake on my answer key. Or I made a mistake here. I believe I made a mistake here with my rotation. Yeah, with my rotation. Sorry about this, guys. I made a mistake. I'm not going to record the whole video over again. But my mistake here is when I rotate 180 degrees, it's just changing the sign of each. So I'm not flipping it around. It becomes positive 1, negative 3. So I'm going from negative 1, positive 3 to positive 1, negative 3. That is my fault. I apologize. Okay. So that's what's happening when you rotate 180 degrees. But now, what I was saying about translation stays true. When I'm translating down 2 units, my x value is going to stay the same, and then I'm going down 2 more, so negative 3 minus 2 is negative 5. Okay, and then dilating by a scale factor of 4 means that I need to multiply each of these by 4. So when I dilate, I'm multiplying my x by 4. Well, 1 times 4 is 4. Negative 5 times 4 is negative 20. This is your final A2. All right, now moving on. We now have what I think is kind of a tricky problem here. And really, in order to think about this one, you just kind of have to focus on one point here and just see what's going on. Okay, now L, if we're focusing on L, and we need to know what is going on in what order we're doing this. Okay, and first it's saying we're translating first, so going plus 2 on the x, minus 8 on the y. Well, already you should see, well, that can't be what's done first and then made bigger. Like, no, that's never going to get you over there, so it's not A. Now, once again, B starts with the translation. We already decided can't be that. That just doesn't make sense. Now here, this is starting with the rotation. If xy is becoming, you're flipping the y and the x and making the x negative, or the second number negative. Okay, so starting with the rotation, this is, let's see, L is at negative 2, comma 3. This pencil is terrible. Negative 2, comma 3. If I'm rotating it or changing it, that's going to make it become L prime at 3, and then I'm changing the sign of my x, so 3, 2. So that would be like right here. Okay, this seems like it could be promising. And then I'm multiplying each of these, so let's do that. Well, multiplying each by 2, it says, so then it's going to be 6, comma 2 times 2 is 4, so 6 comma 4. So now I'm up here with L, and now I'm going right to 1, 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8. That does get me to where I need to be, so that's how I know it's C. So you really just got to focus on one point, take it through each of these, see which one brings you to L prime. It is C. Okay, and then it's asking, well, what is the composition of functions, or for the sequence of transformations that maps the preimage onto the image, basically saying, okay, well, what is all happening to it? And if C is the correct answer, well, first we're rotating it. So the first thing we're doing is we're changing the y and the x, and we're changing the sign on the x. Okay, Second, we're then multiplying each by 2, and this negative needs to stay out front, so I'm going to fit the 2 right in there. Okay, and then lastly, we are translating going up 2, down 8. Those were the things we did, all in that order. So this is your composition of functions. Okay, now moving on to number 9, we have quadrilateral wxyz with the following vertices, and it's being reflected across the line y equals negative x. Well, the line, whenever you're reflecting anything across the line y equals negative x, we know our rule, and it's just asking for z, so I'm taking 6, 2. Our rule for that is that you flip the 6 and the 2, so this is now going to be 2, 6. And you also, if it was just across the line y equals x, this would be it, but it's across the line y equals negative x. So I also need to change the sign of each. And that is it for that one. Okay, moving on to number 10. A segment with endpoints CD and MN is vertically compressed by a scale factor of 3/8, and then horizontally stretched by a scale factor of 5 centered at the origin. Okay, what are the endpoints? Well, all this is saying is that if it's horizontally stretched, well then 3/8 is being multiplied by our x, because our x value, and that I can do that right away for my m also. That's being multiplied by our x value. And then sorry, I cannot talk. Wow, and I made another mistake. Sorry. It is late. I need to go home. Vertically compressed by a scale factor of 3/8. So that's going to actually happen to our y, which is d and n. So that's going to have the 3/8 multiplied by, I'm sorry. And then horizontally stretched, okay, horizontal is our x value by a scale factor of 5. So that's how I know I need to multiply my x by my 5. My x gets multiplied by my 5. And the vertical compression is being done to my d and n because those are my y values. Okay, last page. Thank God for me, because wow, I need to go home. And here we go. We have this polygon KLMNP, and it's being translated using the vector, and it's just asking for vertex K after this translation. So K is currently at, I need to know what K is currently at, and K is currently at -3, 5. And if that is being translated using the vector -1, -7, that means I need to subtract 1 from my x. Well, -3 minus 1 is -4. And then I need to subtract 7 from my y. 5 minus 7 is -2. So that will give me my k prime here that they're asking about. Now it's asking if it was rotated 90 degrees clockwise about the origin, what are the coordinates of the image of now L? So again, I'll go up here, find what L is. L is at -2, 7. And now if -2, 7 is getting rotated 90 degrees clockwise, that's the same as 270 degrees counterclockwise. And our rule for that is to flip our x and our y. So I'll do that first. 7, -2 now becomes, or sorry, -2, 7 now becomes 7, -2. And then it is to change the sign of now our first number. So this was a positive, so it now becomes a negative. This was L prime. All right, and then finally, if it's reflected across the line, x equals -1, and it's just talking about vertex P. So I'm going to go over to P. X equals -1 it's this line, the whole place where x equals -1. Okay, I'll highlight it because you probably can't see where I drew that, but x equals -1 is this line right next to the y-axis. And if I'm going to reflect p over that, I got to count how far away it is from that line. 1, 2, 3. It's 3 away, so I go 3 away in the other direction. 1, 2, 3 away. This is going to be my new p after that reflection. So p prime is at -4, comma -1. And you can't see where I was writing. Okay, so I apologize. I know that wasn't the best video. I made a couple mistakes here and there. I was trying to go fast. I need to eat. I need to get home. It's been a long day. Please forgive me for those mistakes that I made. I'll post the answer key to Google Classroom, and please let me know what questions you have. And as long as you understand these types of problems, you are going to do great on the test. Have a great night, and